Welcome to math class. I'm just kidding, we're still learning Java here, but regardless, we can apply math to Java in various ways, ranging from simple calculations to complex logic problems. Let's learn how we can implement mathematical operators in our code to simplify calculations. Don't expect math in Java to be like calculus. In fact, there are only 5 simple arithmetic operators you should know to manipulate variables. First, I'll talk about those 5, as well as put that together with assignment operators which build off of those arithmetic operators. From the top, Java's basic math operators are addition, subtraction, multiplication, division, and modulus. The symbols for addition and subtraction are the same as what you would see in math class. The plus symbol represents addition, and the minus symbol represents subtraction. However, there are a few key differences. Multiplication uses the asterisk symbol, which can be pressed through Shift 8, and the division symbol uses a /. The modulus symbol uses the percent sign, which can be pressed through Shift 5. My main method here, I'm going to show you how to use all of these arithmetic operators. I'm not going to talk about addition, subtraction, multiplication too much because they're exactly what you'd expect them to be. So I can type int sum equals 2 plus 3. Next line, int diff equals 2 minus 3 for difference. Int product for prod equals 2 times 3. And we can print all of them by typing system.out.println sum plus a space plus diff plus a space plus prod. So we expect 5 for sum, -1 for difference, and 6 for the product. So if we compile and run our code, there you go, 5, -1, and 6. Not too surprising. However, division is a little weird. Remember that int variables can only store data values of integers. If I asked you what's 5 divided by 2, you would probably answer 2.5. Pretending that you only knew what integers were, the answer in Java would actually be 2. What the computer does is that it truncates all values after the supposed decimal point. We can try that out by typing int div for division equals 5 divided by 2. If we print out div by typing system.out.println div, compile and run the code, we get 2, not 2.5. And so in order to get to 2.5, we would have to first change our data type to double. Now, what do you think is going to be printed out if we compile and run the code? Let's do it, and actually we get 2.0. So what happened here was that the computer interpreted 5 and 2 as both ints because they're integers. So when the computer divided 5 by 2, it still got 2. Then the computer had to store that value into div, which is now a data type of double, producing a decimal value of 2.0. So to really inform the computer to use decimals, we would have to either change 5 or 2 to 5.0 or 2.0 respectively. Then you're dividing an int by a decimal, or dividing a decimal by an int, which always results in a decimal. The last arithmetic operator I'd like to introduce is modulus. Essentially, this math operator is used to find the remainder when you divide one number by the other in Java. It's represented by the percent symbol, which is pressed through Shift 5. What's so interesting about modulus is its simplicity. Let's say we wanted to find the remainder of 5 divided by 3. Of course, we could do int rem for remainder equals 5 minus 3 asterisk for times parentheses 5 divided by 3 and parentheses. And this would give us the correct answer of 2. However, we had to use 3 arithmetic operators. As programs, remember, we want to utilize the most compact solutions. So use the modulus math operator in place of my last example by simply rewriting 5 modulus 3 to calculate the remainder of 2, and there's no redundancy. To print it out, we can type system.out.println rem, compile and run the code, you get 2. Now that I've introduced every individual arithmetic operator, one more thing you should know is that Java follows the standard rule of PEMDAS, just like you would in math class. I got rid of E for exponents if you're familiar with that because there is no arithmetic operator for exponents. Before evaluating a math expression, we'll have to consider the order of the operations. The operation within parentheses is always completed first. Multiplication, division, and modulus follow. Since these operators have the same precedence, we evaluate them from left to right if there's more than one. Lastly, addition and subtraction are considered last. Again, be sure to go from left to right if there are multiple operators on the same level. Now let's try an example. Just pause the video and try to solve this problem. Solve for int sol equals this expression. So this might seem complex at first, but once we get the gist of PEMDAS in Java, this problem can be solved easily. First, consider the parentheses. We need to add 2 and 3 in the innermost parentheses, which gives us 5. Then we move on. We consider the times symbol before plus because multiplication precedes subtraction in PEMDAS. Thus, we multiply 5 by 8 to get 40. Once this step is done, we can subtract 7 by 40, and at this point our number should be 33. But we're not done yet. There's still the modulus 5 to a value after the outermost parentheses. Using what we learned about the modulus math operator, let's find the remainder when we divide 33 by 5. So that should be 3. And we can print out typing system.out.println SOL. Compile and run the code, and there you go, we get 3. So great work. Next operator I want to mention is assignment operators. We've been using all along through this video, and it's right here with these equal signs. You've probably practiced with them quite a lot, and what the equal sign does is that it assigns a variable with the evaluated expression. For instance, if I type int value equals 7, I assign value to be an int of 7. I just want to print it out by typing system.out.println value just to show you something. If I type value equals value times 10, what happens is that we first multiply value, which is 7, by 10 to get 70, and then 70 is assigned to value. So before this statement, value is assigned to 7, but after this statement, value is assigned to 70. We can print it out again by typing system.out.println value. If we compile and run the code, as you can see here, value used to be 7. Then after we did value equals value times 10, value was then assigned to be 70. And it turns out there's actually a shorter way to do this. So I'm going to comment out this line, and I'm going to type value times equals 10. It's the exact same statement as above, but of course it's shorter. It does the same thing by multiplying the value by 10 and assigning it back to the value. This can be done with addition as well, so you can type value plus equals 10, which would add 10 to value's current value, 70, and be assigned to a new value of 80, which is 70 plus 10. To test it out, compile and run the code, and you can see all our desired results of transforming value, which eventually ends up to be 80. Nice. Likewise, this function works with other arithmetic operators, including subtraction, division, and modulus. Lastly, I want to show you an operator that's technically an arithmetic operator, but it's easier to explain after showing you what assignment operators there are. So say I have a number, int count equals 1. If I want to increase count by 1, I can do count plus equals 1, which we've just learned, but we can actually just write count plus plus. This just increments count by 1, and count is assigned a number 1 greater than its previous assigned number. We can also do count minus minus, which decrements the number of 1. We can print out count after each of these expressions, so system.out.println count. I'm going to copy this, paste it here, and paste it here too. If we compile and execute our code, you can see that we've increased count, which is 1 by 1, to get 2, and then we decrease 2 by 1 to allow count to be 1. And that's all. Though we may forget its function in computer programming, math is crucial to solving problems in Java. Through the implementation of math operators, programs can tackle harder challenges with ease. And with that, see you in the next tutorial.